Okay, this is our 1.39 numerical. It's quite long but easy. You can see there a ball is thrown with initial speed v0. It's a ball that is located at v0 and at angle theta. Okay, so this is the initial position. Choose axis and y normal to this plane. This is y, which is normal to this plane. Okay, so you can see we have to find that by using Newton's law. We have to find the position. Okay, and this is the two situations, and the position when the equation becomes this, and when there is a maximum position, we have to find this equation. Okay, so you can see first you can see there is an angle phi, and the angle phi which is inclined at the plane. So first we have to break the component. We know that the weight is acting downward, so this is the component. Along x-axis we have the mg sine phi, and along y we have cos phi. You can see when we talk about angles, so this is the, you can see this is the base, and this is the perpendicular axis. So accordingly you can arrange it. So the net force, you can see there, this is the net force, and when we put the values like mg, this is along the force is along the x-axis, so this is the force, and along y-axis the force is this equals to mg cos phi, and along z, obviously there is a z-axis, but there is no ball moving along this axis, so this is obviously 0. So after taking common, cancel the same values to the m. Okay, so acceleration will change into differentiation from second order differential order. Okay, this is along x y z. Obvious, you can see the why we can put there why we put it there obvious x y z. You can see there's three values, there are three axes, x, y, and z. Wait, so now you have to integrate it. After integrating, we'll get this. We have to integrate it with respect to time, so these values remain same. Make sure the angle will not change. Okay, so minus gt cos phi plus c2 plus, always when we integrate there is some constant c3, and this is the same. Here is the ball initial condition. When the ball is at initially 0, it rests. Okay, so when we talk about these components, so you can break it and splitting the component, you will get the three components along x, y, and z. Okay, so after this is the equation 1. Now you can see when we put the value of time 0 at time 0, we can see the values are this. Okay, so c1 equals to 0, c2 equals to 0, c3 equals to 0, as you consider. Okay, you can see that this is the value for c1. It's obvious after putting these values you will get c1, c2, and c3. It's obvious 0. Now equation 1 becomes, so now after putting these values like c1, c2, and c3 in this equation, c1 is equals to, it's obvious, vo cos theta, and c2 equals to vo sin theta, and c3 is obvious 0. So after putting these values we will get these equations. So now you can see, now we have to integrate again this equation. Okay, this first derivative, first order of derivative x, y, and z value, we have to integrate it. Now after integrating we will get this. Again we have to integrate with respect to time, so this there is t. After integrating, t square over 2. Okay, so same the case with this. Okay, and we will add there some constant. It's obvious. So for y, same the case with this, and for z, this that there is constant some c6. Okay, we will name it. You can name any. It's your own choice. You can name them. Okay. Okay. you can see, yeah, now you can see this, there are three these equations when we talk about at time t0. Okay, so yeah, we know that after putting the value of time 0, so we will get the value of c40, c50, c60, same the case. Okay, now equation 2 becomes last equation, like let me show you. So you can name them. This is equation 2 equation. Okay, these three, 1, 2, okay, and 3. So this is equation 2. Now you can see, like the previous case, when we put the values of equation uh, in equation 2, we will get these form. Therefore the ball position is this. This is along x and along y and 0 along z. Okay, to find how long it takes for the ball to return to the inclined plane. So there is, it's obvious, there is inclined plane. You very well know when we talk about the inclined plane, so this is the plane. Okay, okay, so we talk about the plane. So you can see further, now we have to draw these again. Here the situation is when we talk about the time along y-axis at 0. So you can see this is the term. This is the term. It's obvious. This is the equation, x component equation. This is the y component equation. This is the z. So when we put the value of y, so this is the value which is equals to 0 after taking t common. So and post time is 0, and the second time this. So here we can find out the post requirement of question. So after putting this value of, it's obvious when we put the value of 0, so all values there on the position of ball is 0. Okay, so when we talk about these time, so there is some position. Arrange the terms. First you put the t value in this equation in y with respect to time equation. Okay, so after putting equation, arrange it. Okay, you can see, arrange it for you guys. Quite simple. There's nothing new in this. If you're, if you have a good grip in differentiation and integration, so this is the normal case. Okay, okay, now you can see. So we have to arrange it, like we have to put some formulas there. You can see, you can solve it by yourself, it's easy. So we'll get the force position along uh, the axis which we have to find the ball position. Okay, this is the position ball. So take derivative with theta. So now we have to take the derivative with respect to theta. After differentiation you will get this equation. Okay, you can see there. Okay, you can do anything by yourself, like I have integrated this term, like I have to take sine theta first term, and the remaining t v square cos theta plus phi, or divided by g cos theta squared phi is another term. So you can take it by yourself. You can use the product rule or quotient rule, um, whether you are comfortable. Okay, so you will take common, you will get this term. Now close it in the formula cos theta plus theta plus phi. So this is the formula you can very well know. So you can see after adding to theta, cos shift the term cos to the right side. We will get cos inverse 0 equals to 90, or we can say that pi over 2, okay, which is equals to 90 degrees over. So 2 theta and pi going to another, you can easily find out. And theta, which is at maximum position. When the ball is at maximum, so the angle is there. You can see. So now put this term again to this formula. Okay, this formula, because this is the position of maximum position of ball. So this is the angle. Okay, now put this angle formula into this equation again. So now you can see. Okay. So after putting the value of theta, we'll get these terms. After evaluating sine pi over 4 is equals to 1, and sine minus sine pi over 2 is positive. So on top of this, cos pi over 4 is equal to 0, and cos theta over 2 remains same. So this is the value, and when we close this formula, we will get sine pi. Okay, and cos theta is equal to this 1 minus sine square pi. It's obvious because sine square theta plus cos square theta is equal to 1, and after arranging we will get this term. You can see that 1 minus sine square theta is equal to 1 plus sine pi and 1 minus sine pi, and these 1 minus sine pi will cancel to the 1 minus sine. Here there is one equation more. You can do it by yourself. It's simple. We'll get these terms. Okay, thank you.